The sun that's behind me is a polychromatic source of light. What that means is that the sun produces many colors which mix together to give us this whitish light. If you map out how much of each color is contained within light, you get something called a spectrum. Fun fact, this is what physicists and chemists use to figure out how the atom works before we even manage to look at atoms. But unlike the sun, streetlights are monochromatic. What this means is that there's only a single color coming out of the lamp, and that's because this streetlight is a sodium vapor lamp. It's a special kind of lamp that works by exciting sodium atoms in its vapor form with electricity and then de-exciting it to produce light. And for quantum mechanics reasons, the light this produces is exactly the spectrum of the sodium atom. And the spectrum of the sodium atom is, well, just this line. Well, two lines if you squint hard enough. This has the consequence of making everything illuminated by sodium vapor lamps look kind of dead. You might know the color that you see is not only dependent on the material, but also the nature of the light illuminating it. This is why the dress became a whole debacle, by the way. Because the sodium spectrum doesn't have any other color except this dreary yellow, like the red cap on my coffee cup, for example, everything kind of looked a bit strange, because ultimately this is the closest you can get to pure black and white. Okay, now you might be thinking, for something that looks so dreadful, you wouldn't expect it to be everywhere, right? Like, why are these specific street lamps everywhere? Well, there's a bunch of reasons, of which I will explain two. One, this wasn't always the case. Before sodium vapor, there was mercury vapor, which produces a more white and slightly more polychromatic light. That's better than what you get with these sodium lamps. But sodium lamps are more energy efficient and last for a really long time without much maintenance. And mercury in vapor form isn't really something you want all over the place. And today, well, sodium lamps are yet again being replaced by LEDs, for a lot of reasons, but because LEDs are so expensive, it's taking a while for every single normally functioning sodium lamp to be replaced with an LED. Another reason is about astronomy. Say you have a telescope with which you want to look into the sky, but because of light pollution, this might not be possible. However, if everything was illuminated by sodium vapor light, then you already know precisely which wavelength to filter out. So all the astronomers have to do to obtain data is just obtain data as usual, and then you can just filter out the part of the yellow in the light, because you precisely know which wavelength to filter out. You can do this with normal light as well, sure, but if you do that, then you end up removing parts of the actual picture as well. So that makes things pretty convenient. However, this consequence is not just a con, for we can use it to our advantage, as we did. Before green screen, it was a tremendous challenge to try and separate the background from the actor in a moving picture. And one of the earliest forms of green screen was yellow screen. Okay, that's not what they called it, but basically it worked like this. You would position your actor in front of a white screen and then illuminate the actor normally. And then you would illuminate the white screen from behind using a sodium lamp. By doing so, when you capture this with a camera before it goes to the film, you can, like the astronomers, filter out the known wavelength, which is this very specific yellow, which leaves the entire background, except for the actor, black. But in terms of film, what that means is that precisely this portion of the film is left unexposed. And after that, you can use an optical printer to substitute the dark space with whatever the you want. Fun stuff. This entire method is called the Disney method, or the sodium lamp method, and they patented it and they kept using it till they found cooler ways to do background removal. So, in the end, the humble sodium vapor lamp is actually quite cool. It gives you direct insight into what the atomic structure of sodium looks like. It helps astronomers out by giving them an easy way to filter out light pollution, till Starlink and friends completely ruined that. And it also paved way for modern visual effects in movies. Thanks, guys. And also, thank you for watching. This is now the end of the video. Bye-bye. It is 11:30 at night. I should not be here.